Okay, let's do some spanning tree configuration. I'm in Packet Tracer since we're going to be doing some work with switches, and what we'll do is create a topology of like 6 or switches or something like that and interconnect them. And I'll put it in a hierarchy mode like you're supposed to design your network in. Cisco describes a hierarchy-based switching architecture that you should use, where you have a core layer, a distribution layer, and an access layer. So the core is going to be a big modular switch, expensive blade type system, and then your distribution switches might be layered, and the core will be like probably a layer 3 modular, very nice switch. The distribution might be layer 2 or 3, a bit beefier than usual, used for transmitting the frames to and from your core and your access layer. And then your access layer will be the ports that are going to connect to your hosts. So that's end devices, usually very dumb layer 2 switches. They'll be managed, but not much else going on in there. So we'll design it in a similar manner. So we're just going to start dropping some switches into our infrastructure and try to make it a nice little pyramid. We'll do something like that. Okay, and what we'll do is we'll just interconnect these switches. It's going to use crossover cables for each connection, and I really don't care what ports it connects on, so I'm just going to let it do this automatic decision process it does. It's not a big deal. You'll see these connections are showing up as amber, so that means the spanning tree is currently thinking and processing. Spanning tree is enabled by default. That way you don't run into problems if you just throw a switch into a network. And it's currently processing and thinking, and you can see how the regular spanning tree kind of takes its sweet time. We're still thinking. Switch 4 still has a whole bunch of stuff turned off. Switch 3 is still thinking. Okay, we're almost there. And it looks like we're finally converged. So this should be our core. This theoretically would be a fancy big layer 3 switch. I didn't put one in there, but you could easily do so and just drop a 33,000 series in there or something like that. But this will be our distribution switch, and I interconnected our access switches, which you might do, you might not do, kind of how you design your closets and such. We'll just determine that, but that's our diagram for now. So what I'd like to do is have my top core switch, which is supposed to be my big kahuna, is going to be my root bridge. That's what I would like. If we go in there, we can find out some information about whether or not it is. So let's go in and we'll do show spanning tree. If we do show spanning tree, that'll show us per VLAN the spanning tree information. So here's the information about our root bridge. It says, okay, spanning tree is enabled. Here's our root information. This is not the information about my switch. This is about the information it's learned about the root. Then if we look at this, this is the information about my switch I'm in. So this is my bridge information. So if we look, the root ID address is E9EA. And my bridge is C7B0. And if you look at the whole MAC, you can see how this is lower than this one. So this one. Obviously, I'm not the root bridge because these two are different. If these two MAC addresses matched, then I would be on the root bridge. And there's actually a line that'll say, you are the root. Or I am the root, or something like that. It'll tell you right there, and we'll go find it and show that. It'll give you some additional information about the cost of the link. These are 100 meg switches, so it's going to take 2 hops to get to wherever this root bridge is. So it's 38, so it'd be 2 values of cost of 19 added together. So since I'm at the top one and the cost is 38, it's going to probably be one of these two, switch 4 or switch 5. See how all these connections are currently active, and they're 2 hops away, 2 switches away from switch 0. So it's going to be one of these two are probably going to be my my root bridge. So we're going to have to go find him. It also tells you some information about who's connected on what interfaces and what the status of the ports are, the priority, whether it's a point-to-point connection from a switch to switch, or if there's a hub in the way, the cost of the link, and so on. So that's got a lot of nice little information there. So let's go find our root, and we'll show that. So it's going to be one of these two. It's not that one, so our addresses don't match. So let's go check switch 5. There we go. So switch 5, one of my access switches, all the way down here is the root bridge. This is probably the thing that you want the least. So this is not what we want at all. It says this bridge is the root. So what we have to do is, and this has happened because the MAC address is the lowest. So this one, simply because his MAC address was lower. So what we need to do is make this switch up here a root. What I'm going to do is leave all of our VLANs the same, so we're not going to have all these different VLANs going on and different root bridges based on different VLANs. I'll leave that to you in your own lab time. But what we'll do is we'll go in here and we'll force switch 0 to become the root for VLAN 1, for our default VLAN. So what we can do is go into spanning tree. So we're going to go into config mode, and we're going to say spanning tree VLAN 1, and then I can say root, and then if I want it to be primary or secondary. So it's recommended you define both your primary and secondary. And what this will do is this keyword, primary or secondary, will configure it to be the primary or secondary root bridges on your network, and it will ensure that this switch is always primary. So one way of doing it is you can set the priority all the way to 0, and you can do so that instead of using the root keyword, you can use priority, and then you could force the priority to 0, and that would theoretically make this always the root, but you can also do it with the keyword, which makes it a little easier to read. There is a problem with this though. If we force this switch to be priority 0, and then we insert another switch onto the network which had a previous configuration from some other place, and it happened to have a priority of 0 configured as well. Well, now we have two switches with priority of 0, and whoever's MAC is lowest is going to win. So you can have a situation where even though you did the priority level, you may still have some sort of takeover happen and cause problems. So we'll show how to guard against that issue a little bit later. But what we'll do is we'll just use the root primary keyword. Whoops, I'm going to go back. There we go, root primary. So now for VLAN 1, this switch is going to be the primary root. And if you take a look, spanning tree is currently renegotiating our ports. It took switch 5, one of those ports, it stuck it into blocking mode, and switch 0 is currently taking over, spanning tree is calculating, and so on. We're going to give it a second. Here we go. So we got links coming up. So we can go into another one of our switches. Theoretically, we could have another core switch, but you know what? We'll just use one of these. We could go in and say spanning tree VLAN 1 root secondary, and then we could force switch 2 to always be the secondary. So that way we have a consistent configuration for our root bridges. And this is important because if you have links, you see how long that took if you don't set up any of the rapid modes of spanning tree. If you start popping switches in and out of your network and it ends up renegotiating those ports, you have 30 seconds or so for it to renegotiate and do its spanning tree process of blocking, listening, learning, and so on. If you keep doing that, you'll have outages in your network where packets will get lost, and people's websites won't load fast enough, and issues like that, and people will be upset. So you want to have a consistent configuration in your network. So it's highly recommended that you force your core switches, or whichever ones you want, to be your root and your backup root. So another thing we can do in order to protect this this root bridge is we can use root guard. So root guard is placed onto the ports of the root switch that face other switches to guard against them trying to provide us lower priority BPDUs, bridge protocol data units. So what we're saying is we're guarding against the fact that I am root and no one else can be. So anyone who sends us a BPDU saying I'm a better candidate for root, we're going to ignore that. So that's what root guard does. So we're going to go into the interfaces that are used here, and we're going to turn on root guard. So this is FA01 and 2. I'm going to do a range command, and what we'll do is spanning tree, guard, root, and that's all there is to it. And so now we are guarding against other switches sending us BPDUs trying to take over as root. So we don't want that to happen. So you have to do that on each link that connects to a switch. So you'll want to make sure that the ports you have configured for switches are set up correctly and maintained and understood between all your IT professionals in your organization. If they try to hook in other ports that you haven't configured, well, then you could still have a problem. So you got to make sure that you guard root on the ports that are connected to the switches and only to the switches, and don't use other ports that haven't been configured and ready to be used for a switch to interconnect. So we have now properly guarded ourselves. One other thing we can do is, if we have hosts off our access layer, is we can set them into port fast mode. So remember I mentioned how we don't want that delay of 30 to 50 seconds or something like that, where it needs to negotiate the spanning tree and such, especially for a host, because a host could come up pretty quickly and request an IP, and DHCP won't go through because it's still in blocking mode, and then it'll have to retransmit, or it might fail or something like that. So what we can do is we'll put some hosts into our access layer, and then we'll interconnect these. And you can see here how they're waiting, and it's a lot of downtime. So we'll find out what port this is. Looks like we're on 03, 05, and 03. Okay. So we'll go into config mode. We're going to go into FA03, and we're going to set it so that it is in port fast mode. So we're going to say spanning tree, port fast. So right now we just got an error. Well, not an error, but a warning. And it'll say, okay, sure, we'll do port fast, but only if the interface is not trunking. So one thing we have to do also is set this to an access port. Right now it's in dynamic mode by default. Remember I mentioned dynamic trunking is enabled by default on all these. So what we'll want to do is set these to access mode so that we don't have any future problems. Whoops. And we'll do that for the other switches as well. Now these ports were in access mode anyway, so they're connected to a host, so they weren't trunking to begin with, so port fast did take effect immediately, but it is certainly recommended to just set them into access mode, since you don't want people connecting switches to them anyway. Okay, there we go. So now we have port fast turned on those three. So what we'll do is we're going to actually see if it lets me. Okay, good. So I'm going to turn off the interface. So we're going to pretend these things are turned off more or less. So now if we go in, our ports are down because there's no link on them whatsoever. We're going to turn it on. Boom, instantly into forwarding mode. There's no downtime there. If we didn't have port fast enabled, it would have sat there and been in that 30-second downtime. So we can go in there, turn on our port, boom, goes right into forwarding mode. So now when the client boots up, if this were a fresh boot on the PCs, then they would instantly have network connection so they can request DHCP. So one other thing we can do is we still have a potential issue, because what if someone removes their PC from the equation and brings in a switch, and they hook it into their port in their wall, and then that way they can run their laptop and their PC on the same network. I mentioned that kind of example before. So if they do that, even though this is set to an access port, it still could allow them to hook a switch into it, and you could still cause problems. So you'd only have access to one VLAN because it's an access port, but they could still split out their network and connect a switch to it. So one thing you can do is enable what's called bpdu guard, Bridge Protocol Data Unit Guard. What we can do is go into the ports that are access ports that connect to our PCs. So the ones that have port fast on right now. And we basically can just say spanning tree bpdu guard enable. And that will turn on bpdu guard. And I'll do that real quick. Then we'll talk about what that actually does. Okay, so now we've enabled bpdu guard, and what that means is if I connect a switch that uses spanning tree into this port, it will block the port. It'll put it into a disable mode. So that way we don't have any problems. It'll if it detects, once a switch gets connected, it's going to send a bpdu to the switch. So if we have bpdu guard enabled, it's going to say, oh, whoa, 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 no, and then turn off the port. It'll put it into a blocking mode and error disable the port and say, no, that's not happening. So that way we won't send out any bpdus into our network and potentially take over as root down here, and it also prevents the connection of switches. So does it prevent all switches? No, because some of the very most basic switches don't use spanning tree, and you can go into a switch and tell it to not use spanning tree. So we could actually go into the switch first, configure spanning tree to be disabled, and then hook it in there, and unfortunately the switch would have no idea that there is a switch interconnected to it. So there's still ways around it, but it would prevent a good majority of issues that arise. So it's definitely recommended to use bpdu guard on your access ports as well as port fast, and that takes care of a good majority of things that would crop up. We can also change the type of spanning tree that we're using. So we could go into switch 0, for example, and we can change our spanning tree mode. So we can say spanning tree mode, and then we have two options. So we have PVST or rapid PVST. So we could say I want to, instead of using PVST, I want to use rapid. So we can say I want to use rapid PVST. And then of course this switch is going to start reconfiguring things, and we'd have to go in here and set that on our switches. And once these two negotiate, we'll be converged, and we'll be using rapid PVST. So that's really all there is to that. And if you have hundreds of switches out there, that's where some of the other tools, either from a vendor or from companies like Kiwi that make CAT tools and such, you can blast that change out to all of them pretty quickly.